Hello guys, it's again me, Vladimir Pintyev, phone 91, CPC Lab 6. Today we're gonna speak about network attacks, uh, which are actually denial of service attacks. I implemented the slow post attack, which is a layer 7 network attack, which is working at the application level mainly with an HTTP protocol, but for past few years the main attacks were actually the layer 4 attacks, which tried to block the channel bandwidth, to load the server's CPU, memory, and so on. The advantage of layer 7 attacks are that it's very hard to spot them, mainly because the HTTP headers look fine. They're not like bad HTTP requests. If you need, you can fully randomize the content lengths, the time to leave fields, the user agents field. Each attack from each thread could be unique. And the principle of this attack mainly is that it has totally legal it has a totally legal first request header, but the actual payload that is coming after it's fully randomized and sent in a special way. It's like sending one character with a timeout of 16 seconds, any timeout you want to set. And when you're randomizing like strings of 6,000 characters for each of 256 threads and sending each character from that string with a 16-second timeout, you can just compute the values of time it will use to send each request, each post. So we have 60-second timeout, time one character, time 6,000. It's like dividing on like not a minute, an hour, 360. It's like 100 hours only for one thread, sending on one request, and divide it with 24 hours. It's like 4 days. Mainly you can change these values as you want, but I figured out that it is enough to kill most of not properly configured and defended servers. I used two different approaches to check if my attack works. One is on this simple program which is HTTP file server, where you just add files you need, specify the port 18, and on your local IP the server starts to operate. And also I checked it on another machine, an Apache server 2.2 configured with index HTML predefined as in this way. So also, of course, I should mention that there are some old school attacks like TCP SYN flood, which is layer 4 attack. It's modern systems are immune because there are load balancers and like properly configured servers don't react to this attack anymore, and the HTTP slow loaders, which is actually a slow get attack. The main problem of this attack is that it was already patched in Apache 2.2 and Microsoft ESS servers, but there are little drawbacks that it is actually not so strong, because there is ISS Microsoft ISS servers set the timeout limits to HTTP headers received or request. The popular load balancers from Cisco are just dropping all the connections using HTTP get DDoS attack. So the Apache Foundation actually fixed it, because it just sorted through the bad HTTP requests with high content lengths and big timeouts. So that's all. This is why I choose the HTTP slow post attack. Basically because it isn't very hardware consuming, it isn't very resource consuming, because we don't need high high cost hardware to implement it. It's few lines of code. If they're properly structured, your attack tool will work very well. So let's analyze a little bit the code. This is the code mainly. Some predefined user agents randomly selected from different sources, mainly because it helps to prevent fingerprinting of from the server. If from the same user agent there are tons of requests, the server can fingerprint your requests and just drop down them next time when you try to connect. So the main attack, of course, it was implemented using threads. Some usage description. From the very beginning, I start my attack like using these options. It's like the attack is lab 6, and then I should specify the HTTP, the location of the server which I want to attack. Then I call the HTTP attack function, which actually is a handler to my thread, where this site is sent through. There are 256 threads opened. So in number of threads, I start the HTTP post attack, and it prints out the number of threads opened. It appends it to the thread list and starting each thread separately. Then while length of threads is higher than 0, I try to join threads in order to use them properly, because when the actual post is ending, the thread is not more alive and it should join to another thread, or the new thread should start. So calling a keyboard interrupt changes kill received flag to true and starts closing threads. So, and the actual HTTP post attack. It's sending the site and the received flag is false, while the kill received flag is false, not false, true. The while loop works. The actual post is the operating system randomized user randomized string of length 6000. The properly generated post request is post to the index HTML, or we can specify another file if it has some forms, some login fields, any information you can post on it. The HTTP 1.1 request to the host using random choice of user agents specified here, accepting this like this content, it's text, HTML, application, XML, and so on, accepting languages English, accepting encodings gzip deflated. Actually, it is a very nice structures, proper legal HTTP request with accepting car sets, encodings, and keep alive. Keep alive is a random int from 18 to 112. From most sources, it was specified that it is it's the best way to specify keep alive timeout in order to servers to not drop down your connections. Old schools attacks like in slow loris or slow loris, there is keep alive time like 900, 1000, and actually this request can be filtered out, but this is proper keep alive time specified to the most servers like Microsoft ISS and Apache 2.2. Then connection keep alive specified content time type. Mainly this field should be in this way formatted because any information you supply to the internet from forms or any web forms or login screens as ASP.NET web forms and others are of this content type all over the internet. And the content length, of course, will be the length of the post, which is 6000 anytime. We can also randomize this using another proper random int function to randomize the actual post each time. And the second new request, which is, as you see, not finished. In the new request it's illegal, bad request, HTTP request, mainly because we're sending a lot of data, which is the post, and never specifying where it ends. So then we are opening a socket, a sending socket, trying to connect to the server deployed port 80, sending the request, the proper request, and then trying to send in a for loop through the new request each character string, right, each character sending each character with a timeout of 16 seconds, and then just closing the socket. when all the threads are opened and all the information starts sending, our operating system is already sending it, each character per second. It's tried this loop, this try clause starts to throw exceptions, and when we're starting to receive these exceptions, basically we can try if the host is already dead. Mainly that's the whole idea of slow post attack. Now I can show you how it works. This is our HTTP file server. We should run an attack on it. Its IP address is 66. So here it is. All the threads are opened, as you see. 256 threads are opened. Also all the threads appeared in HTTP file server, mainly because its connection limits are set max connections to 200. The result of this attack shows in this way we access the file normally, and now it shows that the server is busy, and how anytime we try to connect it, it shows that the server is busy. When we end up this attack, just breaking the connection, calling Ctrl+C, the server gets up. Also, we can try to attack another machine on the network which uses Apache web server HTTP server 2.2, which is on IP 68. Also 256 threads are opened, and our server is just pending. We can close this connection and open a new. 66, we should specify 68, and here it is. The actual browser is thinking, but the server is not responding. We can try to ping it off. Ping 68. As we see, the ping goes on, it's working, the server is up, but any requests on port 18 aren't possible. So, and in the moment we interrupt this request, the server responds immediately. So it's enough. Mainly I can show you on my test server from the place I work, which is Casa Moderna MD. They have a very nice configured server which is hosted by Starnet. It uses cPanel CMS. I don't know how the servers actually are configured, but we can try to kill it right now. And as you saw, it loaded very well. And here they are. 256 ports are open, and we try to access, and it is inaccessible. As you see, the server is down, no requests can be sent, and at the time we just as you see, it actually filtered out some requests, but also you saw it had some troubles, like giving us an access. How can we kill it? We can raise up the thread number. We can also modify a little bit this random post we're sending. We can raise a little bit time to sleep, and of course specifying new user agents in case of fingerprinting. That's all. Thank you.